Thank you very much for watching. Dr. Sayed is one of our YouTube channel. On this channel, you will learn about cheminformatics studies, about drug designing by using in silico studies. Today, we will learn about PyRx software. This is free software we are using for protein ligand docking. This software is available on Google. And in today's lecture, we will learn about PyRx download and its installation, molecule pdb file, compound pdb file. I already made video and I will put in the link of this video in description. Protein pdb file, also I will put the link of this protein pdb file, how to download, in this video description. And how to make pdb-qt file, we will learn this one. Docking steps, we will learn today. Reading of docking score, how to read and which reading score is the best. And post studies, this one is post studies, very important in protein docking, ligand based protein docking. This one is one of the important step we will learn in detail. So for this, the first step is move to Google, how to download Pyrex software. Pyrex software, free software, free download. Move on and download the first one, this one link, click on. And here is free academic pro and enterprise we having. And look at over there is the windows. For the window, we choose first the free, and here is the download, and move on download. And look, 5 or 4 seconds are remaining, 3, 2 and 1, and next it will start downloading on your computer. So look here, because I already downloaded, so you can download and install like other softwares. For the next one, you have downloaded, and then we move for the next step. Because I already downloaded ligand and proteins, which I'm gonna study on how to dock. This one is the berberine. This is one of the best molecules. So I have downloaded in pdb file. And second one is the proteins 2FOM. This one is my proteins 2FOM. The 4 digits is having a .pdb file of the protein. So in the next step, we will open the Pyrex software and we'll upload our molecule, both molecules, micro and macro molecule. How to upload? Move to file, load molecule, and move to the desktop and docking. And first I will upload protein molecule. You can upload ligand or protein, whatever is up to you, but I'm going to upload to FOM. It's my protein. So here is the protein. Now we have three bars over there, three displays, first, second and third, all having different functions. So here is the docking, and here is the scoring, will come, and some other process, and here is the ligand and our proteins, etc. Here you can watch. So this one is our protein, and check it how many chain it's have two chains. Each chain is cofactor and B is a protein, so we required only chain B for docking. That's why we uncheck it, the chain A, make it pdb-qt. So where after this, right click on, go to auto dock and make macro molecule, macro. So click on. So after a while, it's become the pdb-qt file. It's having more other steps we will learn in coming future, in next futures, in next lectures, about how to make pdb-qt file, because it requires some rigorous work more. But here, for the understanding, for the learning how to do this, it's enough. So now we will upload the ligand. The next one is the ligand, berberine. So here is the berberine, and you can check over there all the number of substances, how many it's carry. Right click, move to auto dock, and now it's make ligand. Click on. After a while, it will become the ligand now. So both our our molecules, ligand as well as the protein is uploaded now. To refresh the Pyrex software is the best way to cross and again open it, so it worked very precise. It's my experience, because it's free software, so it's that's why. Anyhow, we have now both molecules are uploaded. So here the second bar is moved there, and auto dock. So here is berberine PDB-QT file. And down one is macromolecules to FOM. This one is our protein. B means the B chain. Again, plus, click on plus, and here you can easily check the PDB-QT file up to FOM. So now we have PDB-QT file of berberine and PDB-QT file up to FOM. So both molecules are ready for the docking. The next step is down here. Down is start. Now we are going to start the docking. Click on start. When you start, so it's required, here is mentions no ligand selected, no macromolecule selected. First we select the macromolecule of proteins. Now it's down is selected like is mentioned over there. To FOM-B PDB-QT file is selected. So up down here is now our berberine molecule. We will select the berberine molecule is the ligand. When we select, here is one ligand is selected. Remember one thing, for the minimum docking, the criteria is one ligand, one molecule and one protein must be selected for the docking. And for the more, if you have one proteins over here, and you can select 10, 100, 15, 500, 1000 molecules are the compounds for the docking, but only one protein. But you can upload here 10 plus 100 plus proteins over there, but for the docking is only one protein. It's up to your research how many ligands you will select. After the selection, when you check down each one ligand and here the protein is selected, move to forward here. When click on forward, so such type of desktop will pop out. So now we have a little bit study over there. That's why I will try to make it clear for you people. So this one is called the grid box. Grid box is very important because where is present. So after the selections, only software select that place where is the grid box and will start docking on the amino acids which are inside of this box. Because when we move for the further studies, for more studies, and we will do a precise docking, a specific docking like the allosteric based docking. That's why we will make the position of our grid box on our amino acids where we wanna. So like this we will select. In future we will learn about this one, but today because we are going a general docking and I want to show you how it works. That's why we make sure that our grid box is completely cover our chain of the protein. Completely check is all the directions and dimensions is okay. Now if you look at, it's okay and all the directions is okay now. So you make sure that our directions are okay and the better. So look again and here is down. Move down. And so after that, when you make sure that your grid box is okay now and your desired protein is inside in grid box is completely covered, so what will happen? So after that, the software will check the best poses of the protein and where your ligand will dock, maybe on the single positions, maybe on different positions. It's up to the software and up to the ligands where they get a good position and docking score. So now when it will complete and you are satisfied that your protein is now is covered by it completely covered by the grid box, at this stage now you must move to the next step. Next step is here is the forward. Now click on forward. So after this, docking will start. Here down you can check number of stars are coming like 30%, 40%, 50%, 60% docking is over. It's mentioned down. And here is the process like progress is running like this. You can easily. Now our docking is done within a time. So check the berberine score is minus 7.5 is the best affinity score. Binding affinity score is very best kilocalorie per mole. So there are how many poses they selected? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 poses selected by the software and by the compounds on our receptor on our protein. Here RMSD lower boundings. This one is the deviations, how much deviate from the pose. It's mean like minus 6.5 mean that pose having minus 6.5 affinity score. So it's maybe on the deviate from or on the surface of the protein is do dock, but one of the best score is the first one, remain first one, minus 7.5. So here in this step we look best docking score and our ligand pose is there on a protein. You can easily see over there like this one is a protein and here is our ligand is completely inside. So for the further studies of pose is very important in docking. I told you before that pose selection and ligand binding is really important. For the further studies, we will move to autodock here on this wall and click on plus, and after that we will further studies, we will do further study again. Open the PyRx software. So again, autodock, click on the plus. Here, berberine out of PDBQT. After the docking, you will get this one. Berberine mean berberine compounds which we have selected for the docking. And now it's down in this, down of the 2FOM over there. Out, this is the out file of PDBQT. So select this one. Here are the poses, 9 poses of berberine compound on the protein. Now select the protein now. So protein is over there. So we will check the best pose of our docked ligand which having. So for the further we will move on the molecules here on the first, and here is all the checks are over there. If you check it about the protein, when you uncheck, so protein is not over there, the display of protein is gone now because we require the protein. That's why we check this one 2FOMB chain we required. And the next one is berberine. This one is model 9 and model 8, model 7. Uncheck all the models, you will get like this. So here for the further studies, because we require the best docking, where is the best pose, that's why we check the second model too. Now with the first model, how is the best? Look at, and by using the surface area of protein and ligand, we can understand in a better way. For the surface display, we move on the 2FOM, right click and display here, and molecular surface. When we click on, so this one is the molecular surface of our protein. Here you can easily look and look like all the directions and dimensions that your ligand is inside the pose, not on the surface. Here is there is not on the surface, that's why inside the pose. So that's why it is the good and having good affinity score. So like that, and you can for the further visualization click on your first model and on that. So here you can easily visualize in by the better way where is your ligand and compound and your pose and all the surfaces. Okay, so for the further on berberine, first is for the further studies, check it into their molecular surface, and again you can watch, you can see all the directions. Must be careful, must check all the directions. It is very important that your ligand must be inside the protein. So after that, again I uncheck the molecular surface there, and now I will show you the next pose in here. So this one uncheck the first one, here is no, there is no ligand because I uncheck it. I want to show you the second one. Second pose is over there, but the affinity score is near to the first model, but that second model of berberine pose is here. Look at, is very interesting. It's like on the surface of the protein. So if your ligand binding is on the surface of the protein, it's not good for the further studies. Don't make confidence on such type of model, such type of outcomes of your ligand if they dock on the surface of the protein but having good affinity score. This is not the good for the further studies. This is very important for post reading. Post reading is very important in protein docking. Here, if we make it in molecular surface, we can display it. Look at this is very much is too much out of the surface and is not a best docking but having good docking score. Sometimes you get good docking score but the pose is not good. That's why both things are very important. You must have good docking score as well as good pose of your compounds. If your compounds was having very good, so it would be a very good for your docking, and you can prolong, you can proceed your studies for the further screening. So is today our study. This one is our today study, and which we have done now. And here is you can easily. So, my dear students and all the viewers, respectable viewers, in today we will learn about the PyRx software. PyRx software is a free software you can download and you can install in your computer, and you can learn the basics of ligand protein docking. In this video, we'll completely learn about. If you have any query, put down in comments your question, and you can send me email on my email address for the further queries and for your further understanding. Thank you very much.